Course title: Advanced Statistics and Econometrics I. Module 1: Foundations of Advanced Statistics and Core Econometric Concepts. Introduction. Welcome to Module 1 of the course titled Advanced Statistics and Econometrics I. This course is designed to provide you with a deeper understanding of statistical principles and their application in econometrics. The focus is on equipping you with the conceptual and analytical tools needed to interpret economic data and make informed decisions through rigorous quantitative analysis. In this first module, we will cover the foundational elements of advanced statistics, exploring essential topics such as probability theory, random variables, distributions, estimation methods, hypothesis testing, and an introduction to econometric models. These form the bedrock upon which more complex econometric analysis is built. Let us begin by revisiting the essential principles of probability theory as they relate to statistical inference. Section 1: Probability theory and its relevance in econometrics. Probability theory is the mathematical framework used to analyze random phenomena. It plays a critical role in statistical inference, which underlies much of econometrics. Understanding probability allows us to measure uncertainty and model the behavior of economic variables that are subject to random variation. Economists rely on probabilistic models to explain phenomena such as consumer behavior, investment decisions, and market fluctuations. In statistical applications, probability provides the foundation for defining distributions, estimating parameters, and testing hypotheses. It also enables us to evaluate the reliability of our inferences and predictions. Section 2: Random variables and probability distributions. A random variable is a variable whose value is subject to variations due to chance. In statistics, we distinguish between two types. Discrete random variables, which take an uncountable number of values. Continuous random variables, which take on an uncountably infinite range of values. Each random variable is associated with a probability distribution, which specifies the likelihood of different outcomes. Common discrete distributions include the binomial and Poisson distributions, while common continuous distributions include the normal, exponential, and t-distributions. In econometrics, distributions help us to model economic behavior and determine the appropriate estimation and testing techniques for data analysis. Section 3: Descriptive and inferential statistics. Descriptive statistics provide a way to summarize and describe the features of a dataset. This includes measures of central tendency such as the mean, median, and mode, as well as measures of dispersion such as range, variance, and standard deviation. Inferential statistics, on the other hand, involve making predictions or generalizations about a population based on a sample. This includes estimating population parameters, constructing confidence intervals, and conducting hypothesis tests. Both descriptive and inferential statistics are essential tools in econometrics, allowing researchers to understand data patterns and draw valid conclusions about economic relationships. Section 4: Estimation techniques. Estimation involves determining the most likely values of parameters based on observed data. In econometrics, we often use point estimation and interval estimation. Point estimation yields a single value estimate of a parameter, while interval estimation provides a range within which the parameter is expected to lie with a certain level of confidence. The two most common estimation techniques in econometrics are method of moments. This approach involves equating sample moments to theoretical moments and solving for parameter values. Maximum likelihood estimation. Primarily, this method identifies the parameter values that maximize the likelihood of observing the given sample data. Both techniques play a central role in building and validating econometric models. Section 5: Hypothesis testing. Hypothesis testing is a formal process used to determine whether a certain belief or assumption about a population parameter is supported by sample data. The process involves formulating a null and alternative hypothesis, choosing a significance level, computing a test statistic, making a decision based on the comparison between the test statistic and a critical value, Econometricians use hypothesis tests to determine the statistical significance of variables, validate model assumptions, and assess the reliability of their findings. Common tests include the t-test, f-test, and chi-square test. Section 6, Introduction to Econometrics. Econometrics is the application of statistical and mathematical techniques to economics. It allows us to quantify relationships between economic variables, test economic theories, and forecast future trends. The three main objectives of econometrics are: estimation of economic relationships, testing of economic hypotheses, forecasting of economic outcomes. A typical econometric study involves formulating a model, collecting data, estimating the parameters, and interpreting the results. Section 7, Structure of an econometric model. An econometric model typically expresses the relationship between a dependent variable and one or more independent variables. The most basic form is the simple linear regression model, which assumes a linear relationship between one dependent variable and one explanatory variable. More advanced models involve multiple explanatory variables and may account for nonlinearities, interactions, and dynamic processes. Key components of an econometric model include: the dependent variable outcome of interest, independent variables, predictors, parameters, quantify the strength of relationships, error term, captures unobserved factors and random variation. Section 8, Assumptions of the classical linear regression model. The classical linear regression model relies on a set of assumptions to ensure that the estimators are reliable and valid. These assumptions include: linearity, the relationship between variables is linear. Independence, observations are independent of each other. Homoscedasticity, the variance of the error terms is constant across observations. No autocorrelation, error terms are not correlated over time. No multicollinearity, explanatory variables are not perfectly correlated. Normality of errors, the error terms are normally distributed. Violation of these assumptions can lead to biased or inefficient estimates and may affect the validity of statistical inferences. Section 9, Simple and Multiple Linear Regression. Linear regression is the cornerstone of econometric analysis. In simple linear regression, we model the relationship between a single independent variable and a dependent variable. In multiple linear regression, we examine the simultaneous influence of two or more explanatory variables on the outcome variable. Multiple regression allows us to control for confounding variables and improve the explanatory power of our model. Econometricians use regression analysis to test economic theories, evaluate policy impacts, and predict future trends. Section 10, Goodness of fit and model evaluation. Once a regression model is estimated, it is important to assess how well it fits the data. Measures of goodness of fit include: the coefficient of determination, which indicates the proportion of the variance in the dependent variable explained by the model. Adjusted versions of this coefficient that account for the number of predictors used. Residual analysis to check for patterns in the error terms. Econometricians also use diagnostic tests to assess whether the model meets the assumptions of the classical linear regression framework. These include tests for heteroscedasticity, autocorrelation, and normality. Conclusion of Module 1. This concludes Module 1 of the course on Advanced Statistics and Econometrics I. In this module, we have laid a strong foundation in both statistics and econometrics by covering essential topics such as probability theory, distributions, estimation, hypothesis testing, and regression modeling. These concepts form the backbone of quantitative economic analysis and prepare you for the more advanced and applied topics that will be explored in the next module. In Module 2, we will focus on advanced econometric techniques, time series analysis, model specification issues, simultaneous equation models, and practical applications using real economic data.